I'm Bruce Rindahl. I'm the flood warning manager with the district. And our presentation today is, can the past predict the future? I'll try to explain that here pretty soon. Again, I'm Bruce Rindahl, and this will be Brik Zivkovich. We're working on our forecasting tool. Well, let's recap. I gave a presentation last year in 2024, and we talked about a different way of doing our hydrology models. For some of you, I'm very familiar. We do the CUHP in a workbook and a spreadsheet, and all the calculations are done there. They do some amazing gyrations, and the output of the spreadsheet is a text file, which then goes into a swim model. Well, we've decided that was way too slow for the purposes we need, so we put all those CUHP parameters from a spreadsheet and into a database. All the calculations we converted into database commands, and then the output text file from that database is exactly the way the spreadsheet looks. Then we used swim using a Python interface, because the Python interface allows us to do a command line. We can run it at a batch file, we can run it during the morning, and run it each day. And it's very fast. Typical, some of these processes now take 10 seconds where they used to take 30 minutes. So we have 100+ hydrology models. That's our past. We've been doing hydrology models since the 70s. We still have them. They still tell us information. Some of them are better than others. But can that past predict the future for the forecasting? Here's a quick flow chart. A lot of arrows here, but quick idea is everything to the left of the red dashed line, that's all done in the database that we referred to. We take the CUHP parameters, we run percent impervious existing because we're doing existing forecasting, and then we generate this usual effective precipitation, generate unit hydrographs from the basins, they go into the storm hydrographs, and that it gets output to the text file. The other parameter that we added was we can look at the starting elevations for our regional detention ponds. This gives us forecasting from you had a significant storm, the detention ponds are about half full. Now we can say run today's forecast with the existing stage of those detention ponds, which gives us a much better look at what's possible. Then we do everything onto a web page. They're color-coded, everything's green because we didn't have anything too exciting. And we look at each individual location. We can click on it. It tells you what we think we're going to have and forecast. And then you can even, at these locations, look at a hydrograph. This was a fun thing that was before our flood season. This was the end of March. We had almost an inch of rain. We had some flooding potential. And so we ran the scenario through the database and into the swim models. And the dark blue line is what we actually saw at Englewood Dam. And the magenta line is what our model was forecasting. I saw this looks pretty good. We're pretty happy with this. Let's not focus on that. Let's look at another model which may not give me enough results. So it's a quick visual now that we can look at any particular day. Now, last year we said we're going to try to do this. We got the proof of concept done. Then we had to do the hard work, make it operational, put it in the database, make sure it wouldn't crash, get the forecasts in, and find all the models and get them configured. We got all of about 2 models running by the end of the summer. That's all we managed to do. So this winter we've done a lot of work and a lot of effort to put some more thing, and now we've got 35 models running every morning. That's 35 models running twice because we have a medium range forecast and an upper range forecast. So we're trying to get a bracket that we're trying to figure out of what could potentially happen. Last year we had 8 forecast points at these locations, at our stage. Here's a forecasted hydrograph that we can show that visual like you saw on the graphic before. Now going into this year, we have 46 forecast points. And interesting enough, these are the ones that are visual, easily shown on the web display, but we're recording every single element, every node, every link in the swim models. So we have a forecast, peak forecast for every element. And that comes up to 9,755 swim elements that you can point and click and see any particular forecast. Why is this helpful? Because now we can look at crossings, other streets, other locations where we're not having forecast points to take a look at. Now at this point, I'm gonna take a little break and say Laura had this fabulous slide this morning. I wish she would have shared it because it would have been in this presentation. It's not about the predictions, it's about being prepared. So we can throw thousands of numbers at you. The important thing with the color coding and the institutional knowledge is we want to be prepared. So that's where we want to go with here. Now the biggest issue that we had last year and moving forward is we need to get the georeferencing. What does that mean? All our old studies were done with CAD. They were done with that type of thing, and so CAD had its page space, for those of you familiar with it. We want to integrate it with our GIS. The picture on the left is Null Island. Whenever you type in an address for your Google Maps or whatever maps, it says, take me to this address. If you type in the address wrong, it'll go, no clue. How about there? 0 degrees latitude, 0 degrees longitude. There actually is a buoy at that location, and it's euphemistically called Null Island. So we have the same problem here with all the CAD drawings. If you go to location 0, 0 from the Colorado State plane coordinates, 0, 0 ends up about 50 miles west of Lake Havasu. And all our CAD models and everything else for hydrology end up there. Apparently this is not a big common problem in the district. Apparently we do CIP projects out there. We do maintenance projects. Mary Powell from our environmental group said, Bruce, I have this reef edge project. Can you give me the rainfall totals for this location? I went, Mary, it hasn't rained there in 5 years. Why are you doing a reef edge project in the middle of the Mojave Desert? So we're working very hard with consultants and internal to move this forward so we can get even more and more. And we found out this technique can leverage into a lot of different ways, and I'm going to have Brik now explain some of the things we're seeing of what we've come up with that we can use this to move forward.
So what we ultimately developed, the acronym is UHMF. Really, it's just a hydrologic modeling framework that brings everything together, that allows us to make better informed decisions and kind of take a modular approach to different inputs and other things like that. And so this is kind of the general framework that we're seeing. We have input parameters and so on. Bruce kind of covered this earlier in his schematic, but from CUHP to rainfall, running it with SWIM, getting our outputs, and then doing the forecast. So I think the bigger picture here is like just a quick show of hands. Who's ever worked on a master plan, worked with CUHP, worked with SWIM? A lot of people in this room. So I think that moving forward, Bruce kind of showed this UHMF and how we can use it for forecasting. So the proof of concept is there, but kind of thinking bigger picture, kind of reframing this question, thinking about, can this save us time and money? The answer is yes. I mean, cutting it down from 30 minutes down to 1 second, or 10 seconds is definitely a big improvement. Can we leverage this for regional hydrology? We do a lot of individual models versus bringing them all together in one database. So I think that one of the big things here is kind of talking about this kind of fixed mindset, which is where we may have been, but where we're going, kind of making this more of a dynamic system. So the puzzle piece analogy, kind of changing, not so much don't change the rules, but change the game. So this idea of making innovative and strategic shifts rather than being kind of stuck in these norms that we're used to so far. So for those that know me, I like to challenge the status quo. My favorite question is, why do we do it this way? Or are there other ways that we can do it? Kind of taking a different approach, thinking outside of the box. And so, Kydland's law, it says, if you write down the problem clearly and specifically, you've solved half of it. And I think that that's where Bruce and I have really worked over this past year, along with the support from the GIS team and the planning team, to really kind of introduce a new concept and new opportunities. And so before I jump into kind of some of these opportunities, I just wanted to present kind of the current status of where we're at. So in a sense, UHMF is kind of a combination of a bunch of databases, so a study database, hydrology database, which includes everything from SWIM to the subcatchments. We have a model database, which is what Python is running, as well as rainfall database, which I'll touch a little bit more. We have our own individual models. So CUHP SWIM kind of gives us the rainfall runoff, and then kind of that routing network that we're using for with kind of this Python-based approach that we have there. Rainfall analysis, I mean, we're all very familiar with the design storm. Bruce has shown that we can run these daily forecasts with some accuracy. Some models are good. I mean, some are useful. Not all of them are great. And so kind of diving deeper into some of those will really help moving forward. And then also kind of some of the support for these geoprocessing tools. So some things that may have taken a long time, for example, the basin characteristics. Michael Baker's worked on a new tool that really helps us calculate length to centroid, other parameters. We've worked on some Python scripts that just kind of import Dr. Cog data sets and will give us outputs directly of some of these that we use to calculate percent imperviousness. And then also kind of detention rating curves. Our GIS team has helped us build something that kind of uses elevation data, taking a facility boundary and kind of comparing that, what we have in terms of stage storage versus what's actually put into the model. So moving forward, I think that the easiest thing here to kind of talk about is kind of what we're doing is really unlocking a lot of opportunities. This idea, and this slide used to be really long with a lot of text, but kind of breaking it down in kind of some of these big opportunities that we have. Model management, hydrologic analysis methods, and kind of these discovery-driven assessments. And so just to quickly touch on some of these. So model management. I like to call this one the double effective model. So we studied something in 2010 based on old rainfall, but the thing that I want you to kind of focus on is kind of these 3 design points. As part of the 2010 study, we may have called out a proposed detention basin in this area. Years later, local government comes in, they ask us to restudy a tributary. So what ends up happening? If we look at these 3 different design points, maybe the facility was installed. Design point 1 is not going to change, might be based on some old data and some old sources. Design point 2 has been updated, but what do we do about this design point 3? I mean, that detention basin is going to lower flows, so how do we go back and incorporate this into that original larger watershed model rather than just one of these smaller tributaries? So where does this apply? This applies actually in a lot of different cases. So with the UHMF approach, what we're seeing here is that, for example, here's the Tollgate Creek model from 2013. We've restudied it in 2017, and then also restudied a tributary in 2020. What we're able to do with this UHMF is able to go into that original Tollgate Creek model, take out these other basins, and then run the Meadowood Creek, run the Granby, and then actually import these back in. So in a sense, we're kind of building this connection of multiple models together, which actually allows us to kind of start updating and versioning our models to get better accuracy across this watershed. So another item here is this kind of variability to synchronicity. Bruce mentioned we have hundreds of models across the district. You kind of see this mapped on the left side, which comes from our study database. A lot of different methodologies, rainfall, imperviousness, you name it. And then also there's just so many models to manage. It's kind of hard to be able to dive deep into some of these. So with the UHMF approach, what we're really allowed to do is kind of take all these models, put them into a database, and then kind of move forward with updating software, updating design methods, and so on. Another way to look at this, and this is a great figure, thank you Teddy for this one, but the idea here is like, think of these all as individual watersheds. I mean, you notice that we still have models that are effective from the 80s, thinking about rainfall, methods, kind of discretization, imperviousness, all of these different kind of single-based approach models as opposed to applying something that's more of a regional framework that actually allows us to bring this up to date. And so like thinking about the time it would take to go through every single model, a lot of time, a lot of money, but what it really allows us to do is, I mean, by the time we're done making those updates, even if we did them one model at a time, there's going to be another update that's necessary. So kind of thinking about here, about all the different opportunities, I think it's kind of starting to highlight some of that. So kind of the next step here to really kind of focus on is kind of this discovery-driven assessments. And what we mean by discovery is we started with the forecasting approach, and then moving forward, I mean, we found, oh, well, we can probably apply this to design storms. We can probably start incorporating stochastic modeling. Let's take the 2013 flood, let's put it over Englewood. Something like the Boulder design storm versus something that's over Englewood. Like the ability to kind of take a modular approach and really kind of start with alternative assessments, evaluations, and things like that. And then Bruce kind of even highlighted here about our operational use cases. So for forecasting, I mean, emergency operations. One of the big things that we hope to do and local governments hope to do is kind of get folks out there before the news media. I think that's one of the big items here that we've heard from coordinating with other folks. But here, like, just with kind of some of the evaluations and assessments, I could go into a deep dive for all of these, but just to highlight one, for example, we're going to focus a little bit on the rainfall methodologies. So thinking here about all the rainfall methodologies, like we do return periods. They may be based on NOAA Alice 8, 14, but 15's on its way here soon. So thinking about having to rerun all of our models again, time, money, efficiency, and this ability to kind of take a regional approach to hydrologic modeling is where things really kind of start to evolve. So I mean, also like things like non-standard design storms. What happens if we get 2 inches in 30 minutes? Like being able to go in and run some of these models, it takes a long time. But with this approach, incorporating kind of the Python, the SQL, some of these other different programs and technologies, kind of incorporating that innovation really allows us to start to explore other avenues that will help further drive innovation and informed decision making. So why discovery here? I think that it's because opportunities keep growing. I mean, as we continue to have conversations with folks such as City and County of Denver, Boulder, I mean, there's really just a lot of opportunities here where they're interested in something or they know something about their models that's really, really important to understand as it results to making decisions and improving things in that sense. So really, I think the big thing here is that the UHMF, it kind of enables this diverse assessment through a modular structure. So whatever piece you want, I mean, you're able to kind of start looking at that in more detail, whether it's your imperviousness or the methods that are used for discretization, kind of this idea of like supporting a consistent analysis so that what we're doing across our region is consistent. Different scenario testing and kind of this integration of diverse data sources, kind of moving forward, testing sensitivity, validating our models, making better decisions. So in other words, it's kind of a choose your own adventure opportunity with this framework that we've developed. So looking ahead, I think that a lot of opportunities. We're going to continue to work on expanding the coverage. This is kind of just a general map that we're seeing here. So adding more geo-reference models. Denver, who shout out to them and their team, their project for the Denver Storm Drainage Master Plan, which was updated this year, was selected as one of the project highlights at the Esri Geo Design Summit. So it's a big audience, international audience for all the work that they've done there. Integration with other data systems, like talking about the crossings layer, talking about forecasting. I mean, you can even pick a point that's an active, like say you have an active construction project that's going on. Being able to get those notifications out to folks the day before or even that morning to kind of clean up the site, make sure things are going well. Some of the other ones, validation. In this sense, validation to historic storm events. Let's start running our storm events through our existing models. How well are we actually matching? Not just peaks, but also the volumes. Is there a big discrepancy? Are we missing things? And so on. I mean, model reviews and updates. Some of these models that are currently still effective, maybe 15, 20 years old. There's some that are even greater than that. So being able to go in, I mean, as we do capital improvements across the district, new regional facilities, kind of this idea of, hey, let's go into the model, let's update it, let's add another version, and kind of continue moving forward. And then lastly, the documentation. So ideally here, I mean, this is kind of the first presentation we're giving to a large audience, but documenting these results, providing a framework that other folks can use if they want to go in and evaluate certain types of storm events. So for those folks that are familiar with stream stats, like I envision, I mean, there shouldn't be an issue in working with kind of our full stack developer, Justin, being able to kind of incorporate some of this work where, hey, here's our model, here's our design storm, you can actually start running these models and kind of evaluating things moving forward. So with that, I think that just lots of opportunities ahead, looking forward to what we come up with over this next year and kind of as we move forward, kind of helping others. So thank you.